All right, so 631 introduces one of my favorite things, elimination. I don't know what it is that I love so much about elimination, but I just think it's super cool. I think, alluded to it at like in 621 or 622 for a second. But let's go ahead and look here. I'm going to kind of just skip through avoiding all the mess. Again, they're going to have you either isolate an X or a Y and substitute for each other, but I'm just going to jump straight to and show you how you can eliminate something, and it's pretty neat. Literally, you're just going to add these lines together. You can subtract lines, but I would always tell you to add. I just noticed over the years people are a lot less confused if they make one of the variables positive and one of them negative. So you can see if we add these together, I'm going to get 7x, 3y minus 3y, or plus negative 3y. They disappear, and negative 2 plus 16 is 14. I divide by 7. X is going to equal 2. Then I substitute into either one of these. It doesn't matter. I'll substitute it in over here. So 2 times 2 plus 3y equals negative 2. So I get 4 plus 3y equals negative 2. So 3y is going to equal negative 6. So y is negative 2. And now I'm going to grab the other one, and I am going to plug in 2 and negative 2 just to make sure that it works. So 5 times 2 minus 3 times negative 2 equals 16, and 10 plus 6 equals 16. So, hey, these two lines cross at one point, and that point is 2, negative 2. And that, again, is known as elimination. What we're going to find is you can actually multiply the lines before you add them. So there's some really kind of neat things that you can do with elimination. So, again, there's something about just the fact that we're literally adding two lines together that I've always found kind of cool about elimination. So as we move along here, this is sort of showing you all the different steps of elimination like we just did. So I'm going to go ahead and close this and jump to the next part of that, which will be 631b. And we will solve problem 681. So Pat was fishing in a lake competition at Lake Pisces. He caught some bass and some trout. Each bass weighed 3 pounds. Each trout weighed 1 pound. He caught a total of 30 pounds of fish. He got 5 points in competition for each bass, but since trout are endangered, he lost 1 point for each trout. He totaled a score of 42 points. So we're going to write a system of equation, and we're going to figure out how many bass and how many trout he caught. So I'm going to obviously focus on this so I can write my inequalities. So I want to know the number of bass and the number of trout. So I'll say bass is the number of bass, or B is the number of bass, and T is the number of trout. And then I will write my two equations. So the first one, Pat caught a total, each bass weighs 3 pounds. So 3 pounds for each bass, plus each trout is 1 pound, so 1 T or T. And he caught a total of 30 pounds of fish. So this is the weight equation. And then I'm going to write one for points. 5 points for each bass, but then he lost 1 point for each trout, so minus 1 T or minus T, and he scored 42 points. And hey, look at that. It's set up perfectly for elimination. If I add these lines together, I'm going to get 8B. These are going to eliminate, henceforth the name elimination, equals 72, divide by 8. So B is going to equal 9. So we got 9 bass. And again, then we're going to just sort of check it in each equation to make sure that we're right. So 3 times 9 plus T equals 30. So 27 plus T equals 30. So T is 3 trout. That says 3 trout, and that says 9 bass, I promise. And then we'll go over here and we'll sub in both to make sure that it does work. So 5 times 9 minus 3 should equal 42, and 45 minus 3 does indeed equal 42. So there you go. He caught 3 trout and 9 bass. Check that. That's 27 pounds in bass, 3 pounds in trout, and 45 points in bass, minus 3 points in trout. Alrighty, let's keep going with this. to 682. So Annie needs your help. Annie was going to use the elimination method. She was ready to add some value to both sides of the equation to eliminate the x, and she knows the problem, both x's are positive. So this is what I'm talking about on these. You technically could subtract, but I would strongly encourage you to avoid subtracting. And instead what I would do is I would multiply a line by a number, because you can multiply these lines, one or both lines. It's up to you. But what if I multiplied the top line by -1? And I have to distribute that negative. So it would be -2x minus 7y equals -13. The bottom I'd left alone, so it would just be 2x plus 3y equals 5. And if I eliminate this, I get -4y equals -8 divided by -4. So y would equal 2. At that point, I can sub it into either equation I want. I'll sub it into the original top. So 2x plus 7 times 2 equals 13. 2x plus 14 equals 13. So 2x equals -1. So x equals -1/2. And then what I'll do is I'll plug both of them into this equation and make sure that it does work out. So hopefully it will. A negative half of 2 is -1 plus 6 equals 5. So there you go, it checks out. So I think what a good question would be is, what if I multiplied the bottom by -1 instead? Would that have worked? So let's do this exact same problem, but instead let's multiply the bottom by -1 instead of the top. So here we go. Again, same problem, but on this one, again, we're going to multiply the bottom instead of the top. I think last time we did the top. I've already forgotten. It's terrible to get old. Don't get old. Okay, so here we go. I am going to multiply the bottom this time by -1. So the top would equal 2x plus 7y equals 13. The bottom would equal -2x minus 3y, because again I need to distribute that, equals -5. I get 4y equals 8, and you can see I still get y equals 2. Obviously if I sub in, I'll still get the same x, which was like -1/2 or whatever it was. But the bottom line is we proved that we can do it this way. Another thing I want to say is this. This works, it's literally an infinity of ways that you could do this. So what do I mean by that? Well, you may do something totally different than I do, and that's completely fine. And I'm not going to go through literally an infinity because I don't want to be here for the rest of my life. But what if I multiplied the top by -2 and the bottom by +2? Again, I said you can multiply both if you want, so I'll distribute. I get -4x minus 14y equals -26. Here I will get 4x plus 6y equals 10, and you can see I get -8y equals -16, or y equals 2. So that's a different way to do it, but we get the same answer. Or what if we decided that we actually wanted to get rid of the y's instead of the x's? And again, I know I'm doing the same problem several different ways, but it's just because if you're watching this video, I want to kind of answer the question of sort of like, what if I did something different? So what if we tried to eliminate the y's? What if I multiplied the top by 3 and the bottom by -7? What would happen there? Well, I suspect this time I'm going to eliminate the y's, and I'll be solving for x, which is important because if you remember, x equaled -1/2 from way back the first time we did this. So I distribute the 3, I get this. I distribute the -7, and I get this. And you can see now I'm eliminating the y's instead of the x's. So I get -8x equals +4. I divide by -8. I don't need 2 of those there. These cancel. I get x equals -1/2. So, and then if I sub that in, I would get y equals 2. So you can see you get the same equation. There's literally an infinity of ways that you can do this because there's an infinity of ways that you can multiply. I hope that makes sense. And let's go ahead and discard this and finish this lesson up. So it seems like a relatively quick video, even though I just spent a bunch of time on it. All right, so let's see here. No, we need to change the color to white. All right. So here, this one's just set up straight for elimination, right? Those are going to eliminate. Negative y equals negative 4, divided by negative 1, y equals 4. I will tell you, one of the issues I see so often is kids finish here. You're not done. Remember, you're looking for a point in the universe. You're looking for an x and a y. Right now we only have a y. So we're going to grab the original equation. We're going to sub 4 in for the y, and we're going to solve. 8 minus x equals 5, negative x equals, I'm subtracting 8 from each side, right? So negative x equals negative 3 divided by negative 1. So x equals 3. And now I'll grab the other one, and I'll sub in 3 and 4. And let's see what we get. Negative 3 times 4 plus 3 should equal negative 9. Negative 12 plus 3 does in fact equal negative 9. So our ordered pair would be 3, 4. Don't forget, it's an ordered pair. All right, very nice. I didn't leave myself a lot of room here. If we look at this one, we can see the x's and y's don't line up, which isn't a huge deal. So let's just rewrite it. 2x minus 4y equals 14. I'll leave the top, but the bottom, I'll change the order, and I'll get negative x plus 4y equals negative 3. So now the x's and the y's line up. So x equals 11. That was quick. I'll sub it into the top. So just so 2 times 11 minus 4y equals 14. Again, I'm subbing it into this one to solve for the y. 22 minus 4y equals 14. Negative 4y equals negative 8. Y equals 2. So I have x and y, and now I'll sub it into the bottom just to make sure that it works out. 4 times 2 minus 11 equals negative 3. So 8 minus 11 equals negative 3, which is true. So my ordered pair would be 11, 2. That solves this. Again, 11, 2 for both the x and the y. And finally, the last one, you can see nothing eliminates, but we've already talked about this. What if I multiply the top by negative 1? I'll put that in parentheses. I need to distribute to everything. So it will be negative 3x minus 4y equals minus 1. Here I get 2x plus 4y equals 2. These eliminate. I get negative x equals 1. Divide by negative 1. X equals negative 1. Now I will sub it into the top equation. So 3 times negative 1 plus 4y equals 1. Negative 3 plus 4y equals 1. I'll add 3 to both sides. 4y equals 4. So y equals 1. And again, I'll substitute it into the last one. So 2 times negative 1 plus 4 times 1 should equal 2. Negative 2 plus 4 does equal 2. So negative 1, 1 works. I will tell you this. Now, a lot of times after we do this lesson, a lot of kids will say, oh, I like elimination way better than substitution or equal value. Really, it should depend, and there's a lesson that kind of talks about this, what they give you. If they have it set up like this, I think elimination is going to be a lot easier. But if they set it up a different way, substitution may be a lot better. The analogy I would use is like golf. You have different golf clubs, right? And they do different things. So if you're 500 yards from the hole, you don't want to use your putter, you want to use your driver. If you're on the green, you want to use your putter, not your driver. So you really should know how to do both. And then whichever one is more convenient at the time is the one that you should use.